All right, everyone, let's take a look at number 13 in section 3.1. We're going to use the limit definition to compute the derivative of this function at x equal 1. So just recall, here is the limit definition that we can use. F prime of a is the limit as h goes to 0 of f of a plus h minus f of a over h. So I'm going to use this form. We also have the alternate definition, but we're going to use this one. And so notice the value of a that we're finding is find the derivative at x equal 1. So that's f prime of 1, right? We're looking for f prime of 1. So notice the value of a is 1. So everywhere I see an a, I'm going to replace that with 1. Okay. And now we want to evaluate this. Okay, so how do we do that? What is f of 1 plus h, first of all? Well, f of 1 plus h, I'm going to replace x with 1 plus h. So under the radical, I have 1 plus h plus 12, which is h plus what? 1 plus 12 is 13. So I can't break that up any further, right? It's the square root of h plus 13. And then what is f of 1? Well, if I plug 1 in, I get 1 plus 12. I get square root of 13. Okay, so here's where I'm at after I plug in, or when I evaluate the function at 1 plus h and at 1. Notice if I plug in h equals 0, hope you can see that I get 0 over 0, indeterminate form. So how do we fix this? How do we solve this limit? Well, remember, we can rationalize the numerator by multiplying by the conjugate, which is this, right? Square root of h plus 13 plus the square root of 13. Of course, I have to do that to the denominator as well. So the total amount I'm multiplying by is 1. So I'm not changing the value of this fraction. Now up top, we're going to FOIL that out. The square root of the h plus 13 basically squared is just h plus 13. So there's the first. Notice the outer and the inner will be just opposites, right? So this is plus the square root of 13 times the square root of h plus 13. And the inner is negative the square root of 13 times the square root of h plus 13. So those add to 0. Last, negative the square root of 13 times positive square root of 13 is just minus 13. Down below, don't forget, we got h times all this stuff. So I'm going to leave that. You don't want to distribute the h through because it's factored down here. Now up top, obviously that simplifies down quite nicely. H plus 13 minus 13 is just h. And now look, I have that common factor in the numerator and denominator. I can divide top and bottom by h, and I get this. And now this function is continuous at 0. I can plug in directly, and I get the square root of 13 plus the square root of 13 in the denominator, which is 2 times the square root of 13. So the derivative f prime of 1 is 1 over 2 times the square root of 13. Okay. The second part of this problem is to find an equation of the tangent line to the graph of f at x equal 1. So we already have the point. Remember, at x equal 1, the value of the function, if you remember, was square root of 13, right? If we plug in 1 into the function, we get the square root of 13. And we just found f prime of 1. That's the slope of the tangent line. So the equation of the line is y minus y1 equals the slope times the quantity x minus x1 is 1. So here it is. Not the nicest looking numbers to work with, but we can solve for y. Be careful here. Distribute the 1 over 2 root 13. So times x just gives me that. Times negative 1 gives me that. And then to solve for y, I need to add 13 to both sides. Well, what do I get when I add the square root of 13? When I add the square root of 13 to this expression? Well, adding the square root of 13, I can think of it as square root of 13 over 1. And to add, I need a common denominator, which is basically 2 times root 13. So if I multiply top and bottom of this fraction by 2 times root 13, 2 root 13 times root 13 is 2 times 13, which is 26. Okay, so the equivalent fraction is this. They have the same denominator, so now I can combine negative 1 plus 26 is 25 over 2 root 13. So that's the constant term, or the y-intercept for our function. So here it is. Now, just as an aside, we can also rationalize these expressions. You can do that as well. I did the whole problem, well, not the whole problem, but I just started with that slope and then rationalized the slope all right, by multiplying numerator and denominator by root 13, again, multiplying by 1. And when I do that, I get the following. So that's equivalent to this. And then if I redid the problem with that, or at least the equation of the tangent line, same values of x and y, but here's my slope. It's same slope, just rationalized. The denominator is rationalized. And then I get add the square root of 13 to the square root of 13 over 26, negative square root of 13 over 26. And I did the same thing here. Here, the denominator, common denominator is just 26. So by rationalizing the denominator, what I wanted to say is, why do we do that? Well, it just makes adding fractions or subtracting fractions easier. It's easier to find the, arguably easier to find the denominator in that case. And so I get this. So if I were to rationalize these numbers here, I would get these. It's the same. So I would be good with either of these answers on the test. And I think hopefully either one will be good in Achieve. Okay, hope this helps on this one.